Hello, I'd like to welcome you to ELE-240, Sensors and Data Acquisition. I will be your instructor for the course. My name is Gary Millette. I'd like to tell you a little bit about the course. There is also a lab, ELE-230L, associated with the course, and you have to be signed up for both of these courses. So, what we're going to do is spend a lot of time in this course looking at how we gather data. Today, in the year 2020, one of the biggest buzzwords is the Internet of Things, and the Internet of Things allows for electronic control applications that, in the past we never could achieve. The future is kind of bright with things like self-driving cars, e-healthcare, smart cities, smart homes, the smart grid, and so forth. And we've gotten to a point with technology where the enabling technologies like microcontrollers are fairly inexpensive. Access to the internet is ubiquitous, and especially wireless access to the internet. It turns out we can talk to a machine or device anywhere in the world via the internet. And again, these enabling technologies, with their lower cost and their better abilities than they ever have had before, allow us to come up with what we call fourth generation electronic control systems. Some of the buzzwords you'll hear in this course are cyber physical systems. And again, they are enabled by Internet of Things applications. So we will spend some time looking at what the Internet of Things is, what technologies enable it, and then we'll take a look at how would we take the heart of these devices, these Internet of Things applications, which are sensors, and get their data into embedded controllers. Now, sensors tend to give you, raw signals, electrical signals. These signals may be small, they might be very big, and it turns out microcontrollers have a limited range of what they can take a look at. So what we might have to do is do some what we call signal conditioning of the signal from the sensor before we apply it to the microcontroller. There's an interesting little device called an op-amp, and the op-amp is capable of just about any function you want. It's an integrated circuit. They've been around for a long time, and they're quite useful for interfacing sensors that are, again, physical devices that put out a electrical signal. And it turns out we can use these op-amps to take and condition those signals and input the finally conditioned signal into the microcontroller in the form of a digital signal after we've done an analog to digital conversion. Likewise, if we want to take and drive something like a large motor, a small little microcontroller, IC, cannot provide much power, so the output signals from microcontrollers have to be interface to the real world also. And this can be done through power electronics after we've done a D to A conversion of the message coming out of the microcontroller. We'll also take a look at wireless networks because they are an enabler of this technology. We will also take a look at some software like LabVIEW that allows us to do data acquisition, and there will be a couple other topics in the course also that we will have fun with. So, without much further ado, let's get started. Thank you.